the 1800s and electricity just got invented. You can hook up a power source to a load, like a light bulb or a motor. It works by moving a charge across a conductor, using a new force called electromotive force. There was this whole thing about AC and DC debating which is best. Spoiler alert, they're both equally as good depending on the use, even though we mostly use AC for powering houses because it's easier to change the voltage to reduce the power loss over distance. There are many electronic components, such as capacitors, resistors, transistors. Capacitors hold the charge, resistors resist the flow of electricity through them, and transistors are, well, actually I'll tell you later. These new light bulbs are great, but what if there was a way to turn them off? Meet the switch. No, not this for a while now. It can turn on and off things powered by electricity. It's pretty much two conductors that get pushed apart or together depending on the position of the lever. Pretty neat, huh? Conductors are materials that electricity flows through easily, such as copper. Note to self, all materials can become conductors if voltage is high enough. If only there was a way to turn a switch on or off with another switch. Transistors. It is pretty much an electronic switch. It uses black magic called semiconductors. They only let current through when a voltage is applied to the gate. Use many of these to create logic gates. These are the fundamental building blocks of most digital circuits. They can be used to add and subtract numbers, store numbers as memory, etc. The three basic logic gates are AND, OR, and NOT. The numbers are not in the format you're used to. A little thing called binary just got unlocked. Convert numbers like 7, decimal, to ones and zeros to use them in such circuits. One new digit of these numbers is called a bit, short for binary digit. Put 8 of them together to make a byte. Put a lot of them together to make these multiples. The difference between kilobyte and kibibyte is why drives you buy have a seemingly lower capacity than advertised. They advertise the kilobytes, and operating systems usually show kibibytes. New stuff just got unlocked. The arithmetic logic unit could do math and logic operations. Pretty cool, huh? But it also needs memory to hold data between operations. Don't worry, there are circuits for that. Like latches. They can remember what the last input was. Seems useful. The most common types of digital memory we use are ROM. This is memory that is written only once and stays that way forever. Kind of. EPROM. This memory can be erased using UV light. Not very convenient, huh? Meet the EEPROM. This bad boy can be erased electronically. RAM uses tons of capacitors that are either charged 1 or not charged 0. These need to be refilled periodically because they naturally discharge over time. Let's quickly explain all the parts of a modern computer. CPU. This can execute general-purpose instructions. Those instructions heavily depend on the CPU architecture. The most common architectures are x86 and ARM64, and each has a corresponding assembly language that goes with it. Assembly is pretty much human-readable machine code, and that machine code is ones and zeros that a computer can execute. Pretty cool, huh? RAM. This holds data. Duh. It's also really fast and doesn't persist the data when the computer shuts down. It's crucial as it's the place applications are stored when open. Drives. These can be HDDs or SSDs. They store data permanently, kind of. HDDs store data using a revolutionary technique. They use a platter that spins and a playhead that reads-writes the data. SSDs use NAND logic gates to store data. NAND meaning not and motherboard. This connects all the other parts together. It is not just simply wires though. It also stores the BIOS, or at least its successor UEFI, the basic input and output system. This makes sure everything is okay when the computer starts up and passes control over to the operating system. Computers so far have been pretty big. If only we could make them smaller. And smaller we did make them. How? Just make the transistor smaller. Lithography. Computers can now fit on your desk. Actually, scratch that, they can fit in your pocket. Computers need input and output devices, otherwise they're just big or small bricks. If data goes from the computer to the device, it's an output device. If it's the opposite, it's an input device. All of that is pretty useless without software. You have to use an operating system to utilize those resources, as well as run other programs. Connect many computers together to make a network. Now connect that network with other networks through a network of networks. The Internet.